you'd think I'm a data scientist. I work at a major company in Canada, that we build lots of machine learning models and deploy them, and that's what we do all day long. But you would be wrong. Over the last 2 years of digital transformation within Suncor Energy, we've learned that data quality, data visualization, and simple analytics can offer value very quickly and set us up for success in implementing those ML and AI decision-making tools in the future as well as currently. So today, what I'm going to talk to you about is that range of analytics, all the way from descriptive through exploratory, through to predictive and prescriptive, and give you a couple of examples of how we've been able to deliver value at all levels of the data maturity pipeline. So in the spirit of Suncor Energy is definitely safety first is one of our major values that we hold in Suncor. I'm going to have a little brief safety moment here, which is that many of you are possibly students, or you have students in the family. And I'm talking here high school students, university students, folks that are going to go out in the next 1, 2, 3 months and get a job. Unfortunately, our young people often get injured on the job. They don't realize that they have the right to refuse unsafe work. And sometimes they don't realize what unsafe work is. So I will put this out there that if you have young folks in your life, have that discussion with them about thinking about the work they're going to do, having a plan and looking at what the risks are, and making sure they feel confident to step up and refuse to do something if it's unsafe. So let's get going. It's not all about AI. A little bit about me. I think Esioma gave you the full scoop on that, but I will just say that, with all of these different companies I've worked with and the various bits of education I've had over the years, I've also worked through operations, worked in design space, worked in that software space. I've done commissioning, and then also been a business owner. So it's quite a broad mix of things. What I am doing here at Suncor is definitely mixing the best, I think, of that engineering and data science mindset to help our business do better in the data space and, drive more value from our data. So today I'm going to go over a few basic concepts that we use in our everyday work with our business units in data. And then I'm going to tell you a bit of a data story based on some of the work that I've done over the last couple of years at Suncor, and then some next steps. So first off, complexity versus value. A lot of you may have seen this curve before. This is the Gartner data maturity curve, but there's various variations of it out there in the wild. Complexity being the complexity of the analysis, complexity of the data, complexity of the model that you've built on it, and value obviously being, the profits or the value you can drive from that data or the work that you're doing. So the first and most basic type of work that some of you may have done or may have been thinking about is that descriptive and exploratory work. Basically, how do we get the data to tell us what happened? Once we can get our hands around that, we can move on to this next phase, which is the why did it happen? So if we look at, we call it diagnostic. So basically we're looking at that data to try and get some inferences, get more information out of the data, try and look at relationships between variables. Next, we move to predictive. So we try at this point to get the data to help us predict what is going to happen or what's likely to happen. Obviously, we can't be certain. And that predictive work is from our causal insights, right? So it's helping us to determine what variables are causing outcomes that we want or we don't want. For example, predictive maintenance would be one that many people may have heard of. And finally, sort of the end of the road would be that prescriptive or optimization type work. So foresight, what can we do to change the outcome that we think is going to happen? For instance, advanced process control. I was just talking to Esioma about this in the backstage area, right? It's how do we recommend to an operator what to do in order to get the best outcome more of the time or as close to all of the time as possible. So that whole spectrum can be applied to business problems, ranging through that whole complexity chain, and you can gain value at every level. So when I joined Suncor 2 years ago, 2.5 years ago almost, um, Suncor was in the very beginning of their digital transformation. And part of what that transformation, it wasn't just about digital and it wasn't just about tools and technology, um, but it was also cultural. And I can say we're still in the middle of it, 100%. But the journey is to create value from data, right? And one of the big parts of that is data driven decision making. So, how do you move the organization from making decisions based either on one person's experience or because it's always the way it's been done, into that data driven decision making space, really focusing on the data and making sure that you're making those decisions every time from as much data as you can in as logical a fashion as possible. Of course, a big part of that is treating your data as an asset. So oil and gas, for sure, in Calgary, and I think many other sort of refining and process industries around the world, often data is kind of this byproduct. You create historian data, temperatures, pressures, flows, things that go into a historian, they get stored somewhere, and they very rarely get used in any large scale fashion. They might be used in very one off circumstances. So they're treated more like a byproduct. But in order to really think about your data as an asset, you need to treat it that way. And you need to continue to create data and curate your data so that it maintains its quality as an asset. So when I was starting, one of the very first use cases that I got to be part of was was one around hydrocarbon inventory. And what we were trying to do was help our supply trading and optimization organization understand where all of their hydrocarbons were. Um, of course, one of the things that the businesses come to you right off the bat and say is, "Oh, can you build us a machine learning model to help us see where all that data is, to where our hydrocarbons are?" And it's like, okay, we get it, right? Business units and analytics folks, we're all alike. We want to do the cool, new, shiny thing. Um, so to the point of my talk, it's really not all about the AI, but AI can be an important part of it, or machine learning. Recommender engines. I'm sure you've heard lots of stuff over the last couple of days. If you've been around the talks here, people have undoubtedly talked about some of the different machine learning algorithms, ones that you'll be familiar with, like the Netflix and Amazon, right, that take data about you and about your preferences from various sources and recommend things to you. Another machine learning application, one that we actually are in the middle of doing some work on here in Suncor, has to do with predictive maintenance, which I mentioned. For example, we're working on a machine learning predictive model that will help us determine when these ropes, so this is a shovel, these are mining trucks, and this is a big bucket. This is one of our oil sands operations that we scoop the oil sand out of the ground, put it in the truck, and it's, if you can see it in there, a little hard to see, but those gray lines are the ropes. They're not actually ropes, they're large steel cables. They fail over time. And so one of the predictive models we're in the middle of building within our advanced analytics group is to predict when those cables will fail in order that we can change them out before they fail, but not too far before, so that we're not spending money before we need to. Anyway, but you got to start somewhere, right? So back to our hydrocarbon folks, and they wanted to get this great model and find out where they have hydrocarbons. Well, we need to start with the data, which, as anybody who's worked with data will know, it's not always in great shape. And so this is actually some of our early work from that hydrocarbon inventory case, with identifying marks removed to protect the innocent, as it were. But, for instance, we look at time series data. That's what these top two plots are. We can look at aggregated data. We can look at, say, in this case, total volume over a number of different tanks. We can look at the relationships between data. So this is looking at correlations. And what this sort of descriptive analytics tells us are a lot of things about data quality. So for instance, in this top graph, you can see there's a chunk here that was missing. So we had to go back and talk to our business owner and the folks with the data and say, why are these two plots so different when they should be almost exactly the same? It helped us dig to the bottom and find that one of the data quality issues. Uh, Aggregated views. This is something that businesses know is possible, but either because of the restrictions of volume in terms of amount of data, they don't, you can't stick this in an Excel sheet and do it. There's just too many points of data. Or they haven't put it together in the same sort of picture as often our advanced or analytics folks can do. Additionally, we start looking at these relationships between variables. Now, any of you who may have done one of these is called a heat map. What you're looking for in this particular case, you're looking at the variables plotted against each other and what the correlation is between the two. So the darker the number means that the two variables are related to each other. So when one changes, the other changes. If it's a very light number or light color, it means that there's very little relationship or none. And so you can start focusing in on which variables or outcomes are the ones that are most important to the business that you're talking to. So in this case, this is temperature. We found that had very little or no bearing on the volumes that we were looking at. So again, all of this is looking at is this the right data? Are we looking at the right span of data? Are we looking at it in the right way? Now, this can be eye-opening for some businesses because they may have never looked at their data like this. So that alone can drive value because they can look at one of those visualizations and get a real aha moment. The other place that it leads you, as I mentioned, is into data quality. And you may have heard of the term data lake. You may have heard data swamp. It's something we have to, as data professionals, always be on the lookout for. So this descriptive analytics that we're doing definitely helps the business start thinking about that data quality piece, which they may never have thought of before. We're going to look at what types of data do they have? Is it structured? Is it unstructured? What are the sources for that data? Am I pulling this from SAP? Is it coming straight out of a process historian? Is it coming out of some other automated system? Or is it just something that, somebody has scribbled down with a pencil and has scanned in a document? How robust are those sources? Do they cut in and out? Are there things we can do to improve that robustness? And then does all our data have what's called metadata? In other words, once we get all this data together in a data lake, or data warehouse, depending how you want to think about it, am I able to find it? If I'm new to the business or if I'm looking for something in particular, is it searchable? Can I find the data I'm interested in? Then the thing we have to be careful about, and this is very much the tendency, I think, sometimes, is everybody's like, oh, let's just stick all the data in one big old pile. And there we got a data lake. And it's like, no, actually what you have is a data swamp because there's no data strategy around it. There's no data governance. That metadata is missing. And as our friend Carruthers here on the right-hand side says, as his data lake turned slowly into a data swamp, Carruthers regretted not investing more in data quality. And that is a very big focus for any organization that's serious about treating data as an asset. And it's something our organization is working super hard on right now. The other interesting thing that we get out of that very first go at data and building those data lakes and data warehouses is around data literacy and self-serve analytics. So, the analogy of don't just feed someone a fish, but teach them how to fish. They're going to be much more able to help themselves. Same thing goes for data. Once we've paid attention to that data quality and once we've got great data lakes and data warehouses, then we can actually let people and actually teach them how to access that data and how to do things that can help themselves. So, the tool that we use, or major tool that we use in Suncor is Power BI. We're a Microsoft partner, so we use a lot of their tools, but there's many other similar tools. You might think, Tableau or I can't think of another one, but there's a number of them out there. So upping the data literacy in your organization and allowing them to serve themselves. serve themselves. So we've actually got a couple of programs that we do within Suncor in terms of data literacy. So as Sioma mentioned, I do teach at our Advanced Analytics Academy, which helps people understand how to be part of a use case, a data use case, and what their roles and responsibilities are, as well as some basic data literacy. We also have an Analytics Citizen program, which helps people get more in depth with data so that they truly can become self-serving on the data itself. So obviously, as you can see now, all we haven't done any machine learning yet. We're gaining all this value from people having access to good quality data, having it have metadata, and that single source of truth is robust. So descriptive analytics, right? So we need to consistently and clearly describe the what, the how much, the how big, the where, the when, etc. Key to that, good visuals, as we saw, building that data quality. Now, maybe that's all you need. Maybe your value is delivered there. Like 90% of the value is delivered by those descriptive analytics. Guess what? You're done. Move on. Do something else. Let those folks have a go at their own data. They're the business and they know that data inside and out. But now, say you want to go to the next level. So with those data literate folks now, we can start to answer the why. So we can start to look at what are the actual causal or correlative relationships between our data. This is called diagnostic and analytics. It can also be called exploratory analytics, depending on where you draw that line. But this is the kind of thing you're looking for is, does my X variable, in this case, crude price, affect my Y variable, which is my volumes that I'm carrying? And so you can look at, well, the blue line, maybe there's a relationship. Green line definitely looks like one. The red, not so much. But there's lots of empty space here. So, maybe there are some more data quality issues we should go look at. But maybe there's enough here to start investigating and doing a bit more research. The other thing we do at this stage is this is really where we start asking those questions that we would call hypotheses. So are my two pools of data different or not? Do I have enough information in order to say that they are different? So this is statistics, and I know everybody's going to cringe, and they hated statistics when they were an undergrad or as a grad student, but I can tell you that it actually is useful. Once you see how you can use it and help yourself to answer those questions around whether my hypothesis is supported or could be supported or not, it's actually super useful. So this is the diagnostic part where we try and answer those questions. Now, sometimes it doesn't work out so great. And that's actually a really great learning right there as well. Somewhere where you can stop spending money on something because you're not getting anything out of it. So for instance, this is one of the use cases that we did about a year and a half ago, and we were looking at some corrosion results in one of our units. And we were trying to see if we could predict corrosion rate, which would be the y-axis, based on some variables. And I just pulled one of the particular plots here. But you can see that even the red line is not able to really predict the blue line at all. There's very little in the way of correlation, which is the actual data, the blue data. What we ended up doing in this particular case was very quickly, we were able to say that even though the theory was sound, so the hypothesis was sound in terms of predicting when a particular piece of pipe would corrode through, there was not sufficient data to support a model to do that prediction. Now, one of the insights that gave our team was where to put in better measurements so that in future, that kind of model might be able to be used. So there's value there in that we stopped doing some work. We didn't get to an ML or a machine learning model or anything. We only looked at some basic statistics. Similarly, if you've heard of signal and noise ratios, so, in sound processing, look at this graph. You'd never be able to pick the signal out of this noise. So again, it is data quality related. And one thing you learn from all of this work is it's very iterative, right? So you're getting to this point where you have data which has got to be related, and yet it doesn't show up when you start analyzing it. Well, is that my data quality? Do I not have the right variables? right? So now that you've gotten to this point where you're looking at the causal relationships, is that giving me the information that I'm expecting to see? So diagnostic analytics, right? What are the relationships? Use your statistics. The big thing here is understanding your key drivers of your outcomes and of your value. So if you can't get to that point at this stage, there's no point going on to a machine learning model. Additionally, maybe you've got enough information now. So you've got all the value you need out of this. You've rejected your hypothesis. Maybe it's time to go back to the beginning. Maybe it's time to move on and do something different but related. However, if you get past those two hurdles and you say, you know what, we think there's still value here, you've done a business case, looked at some very high level numbers, for instance, finally you can get to what a lot of people think is the cool stuff, right? It's that machine learning and AI. So now at this point, you're going to be able to start predicting and optimizing and recommending search engines, automation, all of those things that we associate with machine learning. I put a little picture of a deep neural network. Of course, there's a million different kinds of machine learning algorithms out there. It doesn't really matter at this point in this talk what we're talking about for machine learning. The important part is you've been through the first two steps, you've gotten the value from the data, and you know that the data that you have is solid and that you actually can use it. So an example of an open loop predictor that we're using currently in Suncor is one of our operations in Base Plant, in how we take our bitumen out of the mine and then we further process it. It's called extraction. And what we're doing is we're able to use measured plant data, so things like temperatures and flows and qualities, and we can optimize. So we truly are doing that predictive into prescriptive. We're optimizing the amount of bitumen we can extract from that mixture of water and bitumen by predicting performance based on measured variables. And we're providing those recommendations to our operators, and they can improve production by following what the machine learning engine is telling them to do. Obviously, you can generate a lot of value this way. I can tell you, though, that if you haven't paid attention to the first two steps and you just jump right to machine learning, it probably will fail. You will definitely find yourself going back in the loop and having to fix some of those problems. So, machine learning, absolutely great, but there's value at those early stages as well. Keep in mind that while the value you can derive from some of the machine learning models and predictive algorithms is great, they also do cost more money to develop, right? They're going to take longer, require more people, and you have to maintain them, right? So that also requires more money going forward. So definitely each case, it's going to depend on your specific business case, but there's lots of value in those early steps. So just to sum up, this is about data value. It's from soup to nuts, right? From the beginning to the end. Describe what happened. So make sure you get those descriptive analytics. That helps to get your businesses super involved in the process. Diagnostic analytics, determining why something happened. Can you understand your causal relationships, or at least correlative relationships between your variables? Guarantee if that doesn't exist, you won't get to be able to predict what will happen. And then maybe depending on your use case, you want to go that extra step and do some prescriptive analytics as well. So, understand your stopping point. Is most of the value gained by the time you've been through the descriptive phase or the diagnostic phase? Maybe that's where you stop. Maybe you should continue. So this is all iterative. You can do it once and say you're done, but probably you're going to end up in a loop. And that's probably the way it should be, because as you go through and you get value out of your data, you'll realize maybe you need more data, or you maybe need to improve data quality in a particular spot. And you can improve as you go, right? Continuous learning and continuous improvement. One thing I will point out, though, is, and this is a common failing among those of us who are engineers to start with, we tend to wait until we have all of the foundation perfect before we take that next step and go to the predictive or prescriptive analytics. It doesn't have to be perfect. It has to be good. You have to be, fairly solidly grounded. But sometimes you got to step out and take a risk and do a little bit of that extra work and see if it works, right? Even if it's less than 100% perfect at the base. So go out there, get some value from your data. Make sure you treat it as an asset. And at that point, I will say thank you very much for listening today. And if you want to ask questions, I believe we've got a bit of time now. Or you can email me. My email and my phone number are on the screen there.
Yeah, thanks, Laura. That was a great presentation. We do actually have some comments here. The first one is a two-part question from Peter. The first question he asks is, for an organization that is in the infancy of transitioning to a data-driven decision-making, what are a few practical first steps you would suggest to an organization to start with?
Okay, great question, Peter. And hi, Peter. I know Peter. I'm glad you attended. Few practical first steps. I would say data literacy is a big one. For me, making sure that the businesses that you are working with understand even what data is. And I say that not facetiously. It isn't just some numbers in their spreadsheet. Being able to visualize data can really help. So getting tools in the hands of the people in your organization who actually do have some skill in that regard. And then I think a big part of that as well is that getting to those same folks, it's kind of getting your champions in the organization, making sure that you have a community that can really work together. It doesn't have to be a formal community. So just an example, within Suncor, we actually have a thing called Data U, so kind of like Data University. And we actually use that to promote broader data knowledge across the organization and let people who aren't part of our advanced analytics group really take part in that transition.
Excellent. And then he had a second part to his question as well, where he also asked, do you have any recommendations for planning and implementing a data lake?
Probably a million of them, but probably I'm not the right person to speak to that. Within Suncor, we call those data developers, or I think a common term in the industry would be data engineers. We also have what's called analytics solution architects. But, to be honest, it's making sure that you have, when you get data into, I'll give you a very broad view. When you get data and you start putting it in a particular location or spot, that metadata is super duper important to avoid your swamp. Making sure that the people who know about the data have helped you extract it and transform it and load it into the lake. Because doing it as just like, oh, it's IT's job, you're going to end up in trouble for sure, because they don't understand the complexities of a particular data source. So you have to have the right people involved, and you definitely have to have metadata. Thanks for the question, Peter.
Yeah, great answer. Next question is from Lee, and they ask, what types of tools do you generally use for exploratory or diagnostic analytics? I would imagine that they differ from descriptive analytics, example, Power BI.
Great question, Lee. We use all kinds of flavors. So descriptive analytics, especially in the hands of our analytics citizens or other folks in the organization, yeah, definitely they're using like Power BI. Within our group, a lot of us use Python, so we're in Jupyter or we're just writing code. There are some very automated tools that Azure has as well for helping to do some of that exploratory work. We have folks in our organization who work in R as well. And if you're an R person, there's some great tools as well within R that get used. That's our shop. I know that there's other folks who use different tools. I know there's a lot of good automated tools out there, but I personally, as a data scientist, for me, it's again, that iterative process where I'm like looking at the data, making some visualizations, often in Python, just so that I can see. And then if I need to make something pretty, that's when I bring in one of our data viz folks, and they've got their own suite of tools that they use. So I hope that answers the question, Lee.
Yeah, that's great. Next question is from Tiago. They ask, is there a practical methodology or workflow that you use to decide on whether a data project requires ML or not?
That's a great question. I would say that the first thing we do is we try to understand what problem it is we're solving, right? Just like anything in industry these days, or in engineering, for instance, you have to understand what the problem is you're solving or the opportunity you're trying to get. And off the hop, most of the times you have a flavor for whether that's going to involve some predictive analytics at some point. So you'll need machine learning. Um, you're going to start with those first few steps. As you saw in the one example I had, we really thought we could get to a machine learning algorithm to determine that corrosion rate. Unfortunately, the data quality wasn't there. So, right off the top, we can usually make an I'd say educated guess. A number of us in the group will have looked at that particular business problem and say, yep, that looks like something we'll probably eventually get to a machine learning model on. But let's go through those first few steps. Let's work with our business. We do this in an agile fashion, so that really involves a lot of iteration. So yeah, I can't say that you can't look at something right at the beginning and say, yeah, for sure, 100% we're going to end up in machine learning. But you do have to go through that iterative process for sure. Thanks, Tiago.
Great, makes sense. Next question is from Pierce. He asks, how do you find your candidates for the Analytics Academy?
Great question, Pierce. So far, what we do in Suncor is, if you are going to be involved with a use case, so the words we use in advanced analytics for project per se is a use case, much more in IT terminology. If you're going to be involved in one from the business, so you're a SME, so subject matter expert, maybe you're the product owner, your business translator, you're involved in it in some way, then you should be part of the Advanced Analytics Academy modules that introduce you to how we work and what the advanced analytics is about. The other people that for sure always go through through the Analytics Academy is anyone new to our group in advanced analytics. Obviously, we want to make sure everybody's got the same foundation when we're talking to the business. So that's how far we've gone with that one at the moment.
Okay, great. And it looks like our last question is from Shabazz, who says, great presentation, Laura, and asks, how often have you switched back from AI/machine learning steps to previous steps, for example, EDA or data wrangling and cleaning?
You know what? That's a fantastic question, because the answer to that is all the time. And I'm not even kidding. Even models that we have in production, where you're actually continually updating the data, there's still cases where you have to go back and, something changed in the process. Now we're going to go back and do some quick EDA. We're going to maybe we have to tweak our transforms that we're doing on the data. Maybe we need a new feature when we're doing our feature engineering. So yes, absolutely. It's something that it is truly iterative. You learn as you go, then you go back to the beginning and maybe change something at the beginning, see what happens, and you're learning from that process. I mean, obviously, you're going to only do those steps that are going to get you closer to a better outcome when you're doing machine learning, right? Like, have you improved your root mean square error, for instance, right? Or your R squared. But you often have to go back and do that EDA.